So we're moving into statistics. In this unit, we're going to talk about several things. We're going to start in this video by talking about organizing data. We'll talk about population versus sample, measures of center and spread, normal distributions and z-scores, and finally we'll end this unit with confidence intervals. Now we won't do all of that in these slides today, but that's where we're headed. All right, so let's start with organizing data. So in statistics, our goal is to collect data, that's numerical information, to describe a population. It's often difficult to collect information from everyone in the population, so what we use is a subset of the population called a sample. We want our sample to be as representative of the population as possible. Now, in this class, we're not going to talk about good methods of choosing a sample, but that's an important thing to think about when you're collecting data. For us, we'll assume that the samples are always chosen in a good way so that we have a representative sample. All right, so for example, if I wanted to describe something about all college students, it's hard to get my hands on all college students. In fact, it's hard to get my hands on even all Missouri Western students. So perhaps I would just randomly select 100 Missouri Western students as my sample and use the information I gather from them to describe all Missouri Western students. All right, so once we've collected our data, we're going to display it in something called a histogram. So here on the right side of, on the left side of the screen, you can see the data collected from each state. What we have is the percent of adults aged 25 or older with a bachelor's degree or higher. And this data is from 2007. All right, so if you look at the left side, I know those numbers are kind of tiny so that we could fit them all in, but you can see, for example, Alabama had 21.4% of adults aged 25 or older with a bachelor's degree or higher. So what we do is we're going to take that data and divide it into equal sized intervals. So what I've done is divided those numbers into intervals of size 3. You can see on the x-axis of my histogram here, so there we go, 17 to 20, and then 20 to 23, 23 to 26, and so on. So I've broken that data into intervals of size 3. And the histogram, the height of the histogram, tells me how many data points fall in that interval. Now you have to distinguish whether the 17 and the 20 are in this bar or if they're in the bar to the left or to the right. So what we usually do is we include the left endpoint. So 17 would be in this bar, but 20 would go in this bar. All right, so the first column here represents the number of states with 17 to 19.9% of adults with at least a bachelor's degree. And if you look at the states on the left-hand side, you'll see that there are 3 such states. All right. We can see from the histogram, for example, if you look at this bar, that there are 5 states that have 32 to 34.9% of adults with at least a bachelor's degree. All right, so when you're given a set of data, your goal is to break it into equal-sized intervals. Make sure that your intervals are equal-sized. We can't go 17 to 20 and then 20 to 25. You have to be going the same equal-sized in each of those bars. And then you just create a bar with height, however many data points lie in that interval. All right, so when you're building a histogram, you have to specify whether those bins, so those intervals, contain the right or left endpoints. For us, we are going to always contain the left endpoint and not the right endpoint. There's no right choice of bins or classes in a histogram, but if we use too few, we get a skyscraper-looking graph, and too many give a pancake-shaped graph. Your goal is to give a graph that gives an accurate representation of the data. Okay, so the purpose of our graph is to help us understand the data, and that should be what drives your choice of how big those classes or those ranges should be. Things that you should look for when you're looking at a histogram are the overall pattern. So what's the shape, where is the center, and what's the spread of the data? And then are there any deviations from that pattern? Outliers in particular are individual values that fall outside of the overall pattern. So if you were to look back at the histogram that we had here, there aren't really any outliers, but for example, if there was a state that had, say, 5% of adults with at least a bachelor's degree, that would be an outlier because that would be separated far away from the rest of the data. All right, so let's try making our own histogram. Suppose 25 students take a math exam and earn the following scores. Create a histogram to display the distribution of scores. So the scores are there in the center of your screen. So the first thing we want to do is make a frequency table to count the number of scores that go in each bin. So I've already made my bins or classes, we use those words interchangeably, range from 60 to 69, and then 70 to 79, 80 to 89, and 90 to 100. Technically, that's 90 to 99. Now, those first values in those ranges, those are going to be what I mark on my x-axis. All right, so what I want to do is look at these numbers and count how many go in each range. So if you look, I've got 62, 67, and where's the last one in the 60s? 68. There you go. So there are 3 in the 60s. Now you want to count how many there are in the 70s. So I've got 75, 79, 72, 77, 75, 72, 78, 76. 1, 2, 3, 4, 5, 6, 7, 8. From 70 to 79. I'll let you pause the video and try to fill in the 80 to 89 and the 90 to 100. So go ahead and hit pause and fill that out. All right, so if you counted those, what you should have gotten was 9 between 80 to 89 and 5 from 90 to 100. All right, so now that we have our numbers, let's switch our color here. Let's build our histogram. So you're going to create your y-axis and your x-axis. Now my x-axis should have a label, and these are exam scores. So let's call this exam scores. And I'm going to mark 60, 70, 80, 90, 100. On the y-axis, those are the number of students that got those scores. So I'm going to say number, that's supposed to be a hash mark, of scores. And here I look at my numbers here and I can see I need to go 3, 8, 9, and 5. So let's go up by ones. 1, oops, 2, 3, 4, 5, all the way up. All right, and I'm going to draw a bar of height 3 between 60 and 70. Because there were 3 students that scored in that range. I'm going to draw a bar of height 8 between 70 and 80. a bar of height 9 between 80 and 90, and finally a bar of height 5 between 90 and 100. And that's your histogram. So make sure that you label your X and Y axes. Make sure that you're going an equal distance between your tick marks here on the X-axis. And make sure that you build this frequency table here to start when you're asked to make a histogram. All right, so our next goal, once we've organized our data and maybe displayed it in something like a histogram, our next goal is to describe the data with some numbers that describe it. So things that describe center and the spread. So for example, here I've got some data from the 2000 census and from the 2005-2009 American Community Survey for mean travel time to work for workers. All right, so the first thing we want to talk about is measuring the center, and we're going to first do that with the mean. So the mean of a set of observations, you've probably calculated this before. You find the mean by taking all the observations and adding them up and then dividing by the total number of observations. So here I'm going to add x1 plus x2 plus all the way up to xn, and since there are n of them, then I divide by n. Now we can write that a little more succinctly with this summation notation here. So this notation is telling me I'm going to start when I is 1, and I'm going to add each xi all the way up until I hit xn, and then I divide by n. That's what that 1 over n is doing. All right, so let's try doing that for this data. So if I want to calculate the mean travel time to work in 2000 for Ohio counties, for the given Ohio counties, I'm just going to add up those travel times here. And I'm going to divide by the number of times I have. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I will divide by 10. All right, you can type that into your calculator, and what you should get is 23.2 minutes. All right, we use the X with the bar over it to denote the mean. You try finding the mean travel time during 2005 to 2009. So that's the first column there. There are only 9 observations, so make sure you're dividing by 9. Go ahead and pause the video and try to find that number by yourself. All right, so what you should have gotten is X equals 24 minutes. Another way to measure center is the median, which we denote with a capital M. The median is literally the midpoint of the distribution. So what you're going to do is take all the numbers in your distribution and put them in order from smallest to largest. Once you've got them in order, the middle number is your median. Now, if you have an even number of numbers, there isn't one thing in the middle. So what we're going to do is take the 2 numbers in the middle and take their average or their mean. All right, so let's look here. If n is odd, the median is exactly your middle observation. So here I've taken the 2005-2009 data and put it in order from smallest to largest. Okay, you can see I've highlighted the median in red. That is exactly the middle number of those 9 numbers. So here the median is 23. For the 2000 data, we had 10 numbers, and here the median is going to be the mean of the 2 middle observations. So here you can see 22 and 23 are in the middle. once I put everything in order. And so the median is 22 plus 23 divided by 2, which gives us 22.5. Now, if I want to measure the spread, after I find the median, what I'm going to do is cut through the center. So I will cut through the median. And if I look at the left half, so the observations to the left of the median, and take the median of those numbers, that gives me the first quartile. And if I look at the numbers to the right of the median and take the median of those numbers to the right, that'll give me the third quartile. So think quartile, we're quartering the distribution. So we're cutting it into quarters. All right, so let's look at the 2005-2009 American Community Survey data first. So we already found the median. Remember, we found the median was 23. So what I'm going to do is cut through the median and look at the numbers to the left, not including the median here. Okay, so there are 4 numbers to the left. So there are 2 numbers in the middle, 19 and 22. And I'm going to use those 2 numbers to find the quartile. Same thing on the right. There are 4 numbers to the right, so there are 2 numbers in the middle, and I'm going to use those 2 numbers to find the third quartile. So here, quartile 1, we use 19 and 22 and divide by their sum by 2. To get Q1 is 20.5. To find Q3, we're going to add 25 and 30, and then divide by 2 to get 27.5. as the third quartile. For the 2000 census data, there were 10 observations. So remember, when we found the median, there were 2 numbers in the middle, and the median was the average of those 2 numbers, 22.5. So what we're going to do is cut the data through the median, which now is in the middle of those 2 numbers. So to find the first quartile, I'm going to look at 18, 19, 20, 20, and 22. So there are 5 numbers there, and the middle number is exactly 20. So there's my Q1. And when I look at Q3, I'm going to look at the 5 numbers to the right of the median. So I have 23, 23, 24, 28, and 35. And so that middle number there is 24, and that'll give me Q3. All right, so I told you to find them, but here they are. Q1 is 20, and Q3 is 24. All right, the 5-number summary for a distribution is the min, the first quartile, the median, the third quartile, and the max, in that order. This 5-number summary describes the spread of your data. Okay. So if we look at the travel time to work for 2005-2009, we found Q1, M, and Q3 already. And the min and the max you can find by just looking for the smallest number in your data and the largest number in your data. So here's the 5-number summary for the travel time to work for 2005-2009. What's the 5-number summary for the travel time to work in 2000? I'll let you try to find that one and see me in class to see if you got it right. Actually, let's list it here on the video. So what's the minimum for 2005? 18. We found Q1. Remember, we took the average of 19 and 22. Which was 20.5. M was 23. And Q3, was 27.5. And finally, the max you can see is 34. So there's your 5-number summary for the travel time to work in 2000. All right, I want you to pause the video and try these 2 examples, and then I'll put the answers up on the screen so you can see them. So go ahead and pause, try them for a few minutes, and then come back and check with the video. All right, so what you should have done is put the numbers in order from smallest to largest first. So what I have is 3, 4, 8, 9, 10, 11, 14, 15, and 23. So I have 9 numbers. The median is the middle number. When there's an odd number of numbers, the median literally is in the middle. So here's my median, 10. Now to find the quartiles, I'm going to cut it in half through the median and look to the left and to the right. So to the left, I have 4 numbers. The quartile is going to be the mean of the 2 middle numbers here. So the first quartile is 8 plus 4 divided by 2, which is 6. The third quartile, we're looking at these 4 numbers, and the middle there is 14 and 15, so Q3 is 14 plus 15 divided by 2, which is 14.5. So my 5-number summary, I need to add in the min and the max. So I get 3, 6, 10, 14.5, and 23 as my 5-number summary. The question also asked you to find the mean. So for the mean, you should be adding all the numbers up and then dividing by 9. And for that, you should get 10.78. For part B, when you put the numbers in order, you get 18, 22, 24, 33, 35, 36, 42, and 45. Here there are 8 numbers, so there are 2 numbers in the middle, 33 and 35. So to find the median, I'm going to take 33 plus 35 and divide by 2. And let me switch colors. To find the quartile, you divide through the median to cut the data in half. So I'm going to cut it in half this way. And now there are 4 numbers to the left. 22 and 24 are in the middle. So Q1 is 22 plus 24 divided by 2, which is 23. Q3 we're going to get by taking 36 plus 42 and dividing by 2. So Q3 you should have gotten 39. And finally your min and your max are your first and last numbers. Okay, so here my 5-number summary is 18, 23, 34, 39, and 45. The problem also asks you for the mean, and the mean I got was 31.875. Okay. So be careful of distinguishing between the mean and the median. The mean you get by adding all the numbers together and dividing by the total number of numbers. The median you find by putting the numbers in order from smallest to largest and then finding that middle number. All right, the last measure of spread we're going to look at is the standard deviation. So if you're thinking about center and spread, when we talk about median, the measure of spread that we use is the 5-number summary. When we talk about mean as the center, the measure of spread we use is the standard deviation. So what I want you to remember is that the standard deviation measures the spread of the data about the mean. All right. Now we can calculate the standard deviation by hand using the formula on your screen. So we call the standard deviation S, and the formula here says that S is the square root of the sum of all of the individual data points minus the mean quantity squared, and then you need to divide that sum by 1 less than the number of observations. Now that formula is a mess. You can calculate it by hand if you want and memorize the formula, but I will not be giving you this formula on the exam because you can find the standard deviation on your calculator. Okay, so I want you to use the functions of your calculator to find the standard deviation. So let's talk about how you can do that. All right, so we're going to look at this data set from our previous example. This was part A, the numbers from part A. All right, so pull out your calculator, and I want you to enter the data button, which you can find on the second from the top row and then third column over. So enter data, and you'll see 3 lists there, and I want you to type in the numbers 8, 11, 23, and so on in list 1. Okay, so you're going to hit type 8 and then hit enter, and then type 11 and hit enter, and continue until you've got all of the numbers. Go ahead and pause the video so you can do that and then come back to get your next instruction. All right, so once you've got those numbers typed in, you're going to hit the second button up in the top left corner and then data. That takes you to the stat menu. Now you'll see 2 options, 1 variable stats and 2 variable stats. You want to pick number 1, the 1 variable stats. So make sure that's highlighted and hit enter. So now what you should see is the 1 variable stats menu. For data, you want to highlight list 1 because that's where we've typed our numbers. If you've got a bunch of lists of data going, you might also have data in list 2 or list 3, and you could highlight the appropriate list that you want. For frequency, we are always going to highlight 1. That means that each of the data points that we've entered appears once in our data list, okay? All right, so make sure that those 2 are highlighted, and then you want to hit calc down at the bottom. So scroll down to the bottom to highlight the calc option and hit enter. All right, now what you should see, oops, and I've got a typo here. What you should see is list 1 because that's where your data is, comma 1. So that's telling us the list and the frequency that we've calculated. All right, number 1 says that n equals 9. There were 9 numbers in our list that you should have entered. So if this n doesn't match the number of numbers in your list, you know you missed something when you were typing it in. Number 2 gives you the mean. See the X bar. Was 10.777 repeating. And the option that we are looking for is the standard deviation. That is number 3. Okay, so number 3 gives you the standard deviation. Here it's called SX. So S for standard deviation. So your answer here is that S equals 6.078. Okay, so there's your standard deviation. And if you were to use the formula on the previous slide, that should be the answer that you get. Number 4 is the population standard deviation. We're going to skip that for now. Number 5, you can see you've got that sum notation. So the sum of the X, so the sum of the numbers that you entered, is 97. So if you add up those numbers, that should be what you get. And number 6 is the sum of the numbers squared. Again, that should say list 1. If you keep scrolling down, number 7 gives you the min value. So min of the X was 3. Number 8 is Q1. Number 9 is the median. A is Q3. And B is the max. Now notice that those 5 numbers are the 5 numbers in the 5-number summary. So you can use this to check that you've got the correct 5-number summary. But what I want to see on your paper is the work that we showed in that example. So list the numbers in order, show me that you can find the middle, that you can find the quartiles, and that you can find the min and the max. Okay, so I need to see that work on an exam, but you can check your answers on your calculator. All right, how do we choose whether we want to use the mean and the standard deviation to describe center and spread of our data, or if we should use the median and the 5-number summary to describe the center and spread? So what that means is that the mean is sensitive to outliers and skew, right? If I throw a really large number in my list, when I find the mean, my mean is going to get pulled toward that large number, right? That large number is going to make the sum of the list bigger, and so when I go to calculate the mean, it gets pulled towards that large number. So we don't want to use the mean to describe center if we've got outliers, okay, or if our data is skewed to one side or the other. So if you've got a picture of a distribution like the one on the bottom, here we've got an outlier and we've got a little bit of a skew, we want to use the median and the 5-number summary to describe a distribution that looks like the bottom left. If your distribution is relatively bell-shaped and fairly symmetrical and there are no outliers, then the mean and standard deviation are appropriate choices to describe your center and spread. Okay?